What's the most resilient parasite? An idea. A single idea from the human mind can build cities, which is why I have to steal it. You might recognize that from the movie Inception, but today we're not talking about stealing ideas from human minds. Actually, we're doing the exact opposite. We're talking about planting them into artificial ones. Because right now, the biggest bottleneck in AI isn't a lack of computing power. It's us. It's the humans sitting at the keyboard, painstakingly typing out prompt after prompt just to guide an AI through a complex task. But what if we could just plant a single high-level idea and literally let a whole society of AI agents figure out the rest autonomously? Welcome to This Explainer. Today, we're diving into a genuinely fascinating research paper that tackles this exact problem. It introduces a framework called CAMEL. Now, that stands for Communicative Agents for Mind Exploration of Large-Scale Language Model Society. Yeah, it's a mouthful, but the concept is an absolute game changer. The researchers have figured out a way to create autonomous AI societies where agents collaborate, role-play, and complete really complex tasks with almost zero human handholding. It is a massive leap forward in cooperative AI. Okay, let's dive right into this. We're going to cover the prompting problem, the role-playing framework, something called inception prompting, a real-world trading bot example, agent challenges, and finally, what this means for the future. First up, Section 1, the prompting problem. If you've played around with any modern large language model, you totally know the drill here. It's the traditional human-in-the-loop approach. Let's say you want an AI to build a piece of software. You can't just say, hey, build this. You have to write a prompt, read the output, fix its mistakes, write another prompt, and babysit it step by step. And here's the kicker. It requires you to already be an expert. If you don't know how to code, you really won't know how to prompt the AI to code for you. It's exhausting. In contrast, the CAMEL researchers are proposing true agentic autonomy. You just input one preliminary idea, and the agents take the wheel, steering the whole task to completion while you just sit back. Section 2, the role-playing framework. So how did they actually build this? Well, the methodology breaks down into a remarkably clean flow. Input to process to output. Step 1 is the human input. That's our single seed of an idea, plus we assign 2 roles. Step 2 introduces this brilliant little intermediary called the task specifier. See, conversational agents need highly concrete instructions to work well. So the task specifier basically acts as an imagination module, blowing up the human's vague idea into a super detailed technical prompt. And finally, step 3 is the role-playing session itself, where 2 distinct AIs, the AI user and the AI assistant, chat back and forth to actually solve the problem. And this brilliantly illustrates how it all comes together. We start with the human user, just tossing in an idea, like develop a trading bot for the stock market. The human assigns the roles, a Python programmer and a stock trader. That goes into the task specifier, which generates a highly detailed project scope. Then, the real magic happens. The role-playing session kicks off. The AI user, acting as the stock trader, starts giving step-by-step instructions. The AI assistant, acting as the programmer, writes the code, explains the solution, and ends its turn by asking for the next request. And the human? Completely hands-off at this point. No way, right? It just runs on its own. Section 3, inception prompting. Now, you might be wondering, if you just leave 2 AI chatbots alone in a room, how do you stop them from going completely off the rails or hallucinating? Well, the researchers solved this with a technique they call inception prompting. Actually, scratch the technical term, think of it more like a movie director giving 2 actors incredibly strict character motivations, boundary rules, and a safe word right before yelling action. Unlike typical prompt engineering, where you constantly have to course-correct the AI, inception prompting happens purely at the very beginning. It auto-prompts the agents with specific rules, never forget your role, never flip roles, always end with next request, and only reply with a specific done tag when finished. Once those guardrails are planted in their minds, the loop just runs perfectly on autopilot. Section 4, the trading bot example. Let's make this abstract architecture super concrete by walking through a real-world use case from the paper. They spun up 2 specific agents. First, our AI assistant, who is instructed to totally embody a Python programmer. It's the task executor. Second, our AI user, instructed to embody a stock trader. It acts as the task planner. Remember that really vague human idea of just wanting a trading bot? The task specifier brainstormed that into a highly specific objective. Develop a trading bot with a sentiment analysis tool that can monitor social media platforms for positive or negative comments about a particular stock and execute trades based on sentiment analysis results. Boom, concrete engineering goal. Now the stock trader AI breaks this down. Its first message to the programmer is just, Install the necessary Python libraries for sentiment analysis and stock trading. The programmer AI replies with the exact terminal commands to install Tweepy, TextBlob, and Y-Finance, and simply ends with next request. They iterate like this, writing the entire application line by line. It's literally a perfect simulation of a client-contractor relationship. Section 5. Challenges in Agent Cooperation. Of course, anyone who works in tech knows that things rarely work flawlessly on the first try. Honestly, the most fascinating part of cutting-edge research is often the bloopers. The researchers cataloged 4 major ways things go wrong when AIs try to collaborate. First is role flipping. That's when the assistant gets tired of taking orders and suddenly starts giving commands to the user. Second is assistant repeats, where the assistant just echoes the instruction back like a parrot, making literally zero progress. Third is flake replies. The assistant confidently says, "I will write a script to generate all inputs," and then just stops typing. It flakes out. And fourth, my absolute favorite, infinite loops. Because these language models are heavily trained by their creators to be super helpful and polite, they can easily get trapped in an endless loop of extreme courtesy. The user says, "Thank you, goodbye." The assistant replies, "Goodbye." And because neither is programmed to just leave the other hanging, they just keep saying goodbye to each other forever until the token limit completely crashes the system. The funniest part is, sometimes the AI even notes it seems like we are stuck in a loop, but it still can't break out of it. To rigorously study these quirks, the researchers didn't just run a handful of tests. They scaled this up massively, generating 25,000 automated conversations for their AI society dataset. They paired up 50 different assistant roles with 50 user roles across a huge variety of tasks. Now, what's really interesting about this data on why these conversations terminated is that massive orange slice. 52.4% of the time, the run failed because of the assistant instruct flag. That means over half the time, the AI assistant broke character and tried to boss the user around, which triggered a system kill switch. Only 34% actually reached the natural end of task. So this illustrates a really deep alignment challenge. Current models just struggle to maintain a subordinate, instruction-following persona over a long, multi-turn conversation. They also ran ablation studies, which is basically just tweaking the rules to see what happens. You'd logically think that giving the AI a complex task planner before starting the chat would help it stay organized, right? Well, the results show the exact opposite. When they added a task planner, the number of useless flake messages absolutely skyrocketed to over 100,000. It turns out overcomplicating the initial prompt actually degrades the agent's ability to execute concrete steps. Simple, strict rules worked way better. Section 6. The Future of AI. So, what does this all mean for us? Here are the key takeaways. CAMEL successfully proves we can remove the human bottleneck from complex AI workflows. By using inception prompting and role-playing, we can generate massive, high-quality datasets automatically. And this isn't just about getting AI to code a trading bot for you. It's about generating the data needed to train the next generation of even smarter language models. It also exposes vital alignment challenges, like role flipping and flake replies, that we have to solve before trusting these systems in the real world. Ultimately, it paves the way for cooperative AI societies where multiple agents with different expertise team up to solve problems together. And that leaves us with a pretty profound question to wrap things up. As we move from solitary AI chatbots to entire autonomous societies of agents, communicating, collaborating, and executing tasks completely without our supervision, if AI agents can build their own societies, how do we ensure they remain aligned with ours? It's a wildly fascinating frontier, and the CAMEL framework is really our first map of this new territory. Thanks for joining me on this explainer, and keep exploring.